Hi, I'm Professor Goins and welcome to the Math Professor's YouTube channel. If you're looking for videos explaining topics in pretty much any college mathematics course, please consider subscribing and checking out our playlists, watching our videos, and then any commenting, sharing, liking are greatly appreciated and help our channel to grow. So please consider doing those things for us. It's free, so why not? Okay, let's take a look at the current video. Let's take a look at how to solve absolute value equations. First and foremost, let me go ahead and define what the absolute value of a number is. So definition, the absolute value of a real number, let's call it C, is the distance from C to 0 on the number line. Okay. So the absolute value of a number is actually a distance. In particular, it's never going to be negative. It could be 0 or it could be positive, but it's never going to be negative because distances are always non-negative. The notation is I take the number C and then just on either side of it I put two vertical lines, and we read that as the absolute value of the number C. Let's look at the following sketch or following example, and then we'll sketch it. If I want to look at the absolute value of 4, make that a vertical line, or the absolute value of -3. Well, conceptually, again, this is the distance from 0 on the number line. So let's get a picture for that. So 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So in other words, this goes on the number line from -5 to 5. If I want to identify the absolute value of 4, well, what we're going to do is we are going to find the number 4 on the number line. We're going to locate that. And then the absolute value of 4 is the distance. In other words, the absolute value of 4 is how many units away that number is from 0. Well, clearly it's 4. So the absolute value of 4 is 4. On the other hand, if I look at the absolute value of -3, go ahead and identify -3 on the number line, okay, which of course is right here, and I want to identify its absolute value. Well, remember that the absolute value of that number is the distance from that point to 0. In other words, how many units away is that number from 0? And of course, that would be 3. Okay, so even though the number is negative, its absolute value is positive. Okay. What about if I gave you or asked you about the absolute value of the number 0? Okay. Absolute value of the number 0. Again, on a number line, let's go ahead and sketch that. 0, 1, 2, 3, 1, 2, 3. So I went from -3 to 3. For the absolute value of 0, well, let's locate where 0 is on the number line, which would be, of course, right here. And how many units away is 0 from 0? Well, they're right on top of each other. It's the same thing. So therefore, the absolute value of 0 is 0. Right? Well, with that concept out of the way, now let's transition to looking at equations. And the starting point is looking at something like this. What if I said, what is the absolute value, or if the absolute value of x is equal to, let's say, 2, okay? And I wanted to identify the solutions for this. Well, once again, my starting point is to go to a number line, and let's say 0, 1, 2, 3, 4, 1, 2, 3, 4. So on my number line, I went from -4 to +4. Okay. Well, go back to the definition of what the absolute value means. It's the distance from 0 on the number line. In other words, what this equation is saying is identify the locations that are 2 units away from 0. Well, how many different directions can I go from 0 on the number line? Well, it's just a line, so I can go to the left or to the right, right? It's not in a plane, which would give me a circle, but we'll talk about that later. The idea is on the number line, I can only go 2 different directions, and therefore the locations of the possible x values would be here at -2 and at +2. Okay. So the solutions to this equation, if the absolute value of x equals 2, the solutions would be x is equal to -2 or +2. Well, let's look at the 3 general cases, and then we will look at some specific examples of those. Here are the 3 general cases that we can have for solving absolute value equations. I have the absolute value of, let's say, u of x is equal to a constant c, where c is greater than 0. Okay, let me leave some space there. I could also have the absolute value of u of x is equal to 0, or I could have the absolute value of u of x is equal to c, where c is less than 0. Now, I'm using u of x here instead of, notice this equation here, I've just got an x, because we could have, inside of my absolute value bars, I could have an expression that is related to x. I could have 2x, or x plus 1, or x squared minus 9, something like that. In other words, this is just generic notation for an expression that involves the variable x. Now, here are the 3 situations. If u of x is equal to c, then that means that on my number line, actually, let me put this without tick marks. Well, the value of u of x itself could be positive c, so u of x could be c, or over here at negative c, u of x could be negative c. Just like in this previous example, if the absolute value of x itself is 2, then x could be 2, or x could be -2. So I've got 2 different locations on the real line that the value of u of x could be equal to. On the other hand, if I have u of x is equal to 0, again, on my number line, this says that the value of u of x is 0 units away from 0, and that must mean that the value of u of x is right here. The value of u of x is equal to 0. For this last case, if u of x is equal to c, where c is negative, well, remember that the c value is my distance. The c value is the distance. Just like over here, the number 2 is the distance. There's nowhere on the number line that I can plot a point or a value of u of x that will have distance that is negative away from 0. In other words, if you have this situation, you can, at this point, you can say that there's no solutions, because there's no way that an absolute value is going to be is negative. Distance can never be negative. The only solutions that we could have would be for the first 2 cases. So let's go ahead and take a look at examples of each. First example, let's look at the equation, the absolute value of x minus 3 is equal to 2. The absolute value of x minus 3 is equal to 2. Let's say solution. If I look at this chart over here, where it explains how I set up this sort of equation. Notice I've got the absolute value of an expression in x is equal to a positive number. That's this scenario right here. This says that there's two possibilities. The value of x minus 3 could be positive 2, or the value of x minus 3 could be negative 2. What I do is I set up two equations. X minus 3 is negative 2, or x minus 3 is positive 2. The value of x minus 3 can be one of those two possible values. Now I have a pair of linear equations. And to solve this, right, I'm going to do the inverse operation of subtracting 3. In other words, I'm going to add 3 to both sides. Add 3, they cancel. Add 3 over here, negative 2 plus 3 is 1. That gives me x is equal to 1. Over here, if I add 3, I get x is equal to 5. And again, this says that the solutions would be 1 and 5. You can check those. If I plug 1 in, 1 minus 3 is negative 2. Absolute value of negative 2 is positive 2. If I plug in 5, 5 minus 3 is positive 2. Absolute value of 2 is 2. Therefore, that one checks as well. But let's actually do this a different way. I'm going to call this solution 1. Let's go down here and look at solution 2. Because I want to do this one using a number line. And again, in practice, solution 1 is more than likely the way that you'll do it. But just to give you another interpretation of this and to emphasize the distance idea, remember what the absolute value of x was, the distance from 0. If I interpret this right here, this says that the distance between x and 3 is 2. In other words, if I go to my number line, let's say 0, 1, 2, 3, 4, 5, 6, so this goes up to 6. This says that the distance between x and 3 is 2. Phrased differently, x is 2 units away from 3. So let's identify the point 3. And the distance between x and this number is 2 units. That means I can go 2 units this way, or 2 units this way. What are those values? 1 and 5. And that's what we just came up with, was 1 and 5. Either way works. I would say in practice you're going to use solution 1 more often, but solution 2 is another way to consider that. Now, of course, solution 2 is only applicable if I have a linear equation. If I have a quadratic equation, then you're going to want to use solution 1. Okay. Now let's take a look at a second example. Let me add a couple things to this. Let's say 3 times the absolute value of 2x minus 5 minus 12 is equal to 0. Okay. Well, all these cases over here that I have on the left, even though this one is equal to 0 here, it's not this case. Okay? Because notice here I've got the absolute value isolated, absolute value isolated, absolute value isolated. To solve this, that's the first thing that I have to do, is I have to isolate the absolute value term. Okay, let's go ahead and do that. I want to leave these 3 cases up here, so I'll go ahead and erase what I have in this previous example. To isolate this, first thing I'll do is I'll add 12. That would give me 3 absolute value of 2x minus 5 is equal to 12. Then I got to get rid of this 3, and since this is 3 multiplied by the absolute value, I'll use the inverse operation, which is division with the same number. Therefore, divide both sides by 3, and I get the absolute value of 2x minus 5 is equal to 4. This then again looks like this first case up here. Absolute value of an expression in x is equal to a positive number. This then splits into a pair of equations. Be careful not to say a system of equations because they're not going to be true at the same time, but it's a pair of equations. There's two of them. So 2x minus 5 equals negative 4. Over here I've got 2x minus 5 is equal to positive 4. Solve these. If I add 5, I get 2x is equal to 1. Therefore, x would be equal to a half. Over here, if I add 5, I get 2x is equal to 9. Divide by 2, I get x is equal to 9 halves. And those would be the two solutions to that equation. Okay. Another example, let's take a look at the absolute value of 9x minus 7 is equal to 0. Well, that's going to be this middle case. Absolute value of an expression in x is equal to 0. Notice I have the absolute value here is isolated, and it's equal to 0, which is not the case in the previous one. Even though I had equal to 0, the absolute value wasn't isolated. Since this is isolated, I can go right to, well, the only solution possibility would be if the expression inside of the absolute value bars was actually equal to 0. Okay? To solve that, add 7. 9x is equal to 7. Divide by 9, I get x is equal to 7/9. So that would be the only solution to this. Okay. Look at one more example. Negative 4 times the absolute value of x minus 5 minus 12 equals 0. Once again, this is equal to 0, but it's not this case because the absolute value term is not isolated. Let's go ahead and isolate it. Add 12 to the other side. Divide by negative 4. And of course, 12 divided by negative 4 is negative 3. Let's look back at these three cases. I've got the absolute value by itself is equal to a constant. Well, what do I know about that constant? It's negative. That's what I have down here, equal to c, where c is negative, and there's no solutions. Therefore, this one has no solutions. It's very common to make mistakes on this particular case by forgetting that there's no solutions and doing the following. Again, this is not correct, but it's common to then say, all right, well, x minus 5 would be negative 3, or x minus 5 would be positive 3. Let's just quickly run through that. I'll erase it at the end. Add 5 to both sides, I get x equals 2. Add 5 over here, I get x equals 8. And you're like, okay, great, there's my solutions. But check them. Let's just check 2. If I plug 2 in, 2 minus 5 would be negative 3. The absolute value of negative 3 is positive 3. Negative 4 times 3 would be negative 12. Negative 12 minus 12 would be negative 24, not 0. Therefore, this one does not work. Same thing with the number 8. And so it's a good idea when you're solving absolute value equations, especially when you're first starting them, check your answer in the end, just to make sure you didn't make this one mistake. Okay, it's pretty quick to go back and check these, and it is a good idea to, again, give you peace of mind that you didn't make any mistakes along the way. Okay. Thank you for watching, and please consider subscribing.